Hi, my name is Madeline and welcome to my oral paper presentation. I will be discussing a paper by Thunell and Thorpe called Memory for Repeated Images in Rapid Serial Visual Presentation Streams of Thousands of Images. Our brain has the amazing ability to recognize repeating stimuli throughout our everyday life. Identifying repeating stimuli and having memory of these stimuli is vital to learning. Think about when you were a toddler. How did you learn? Constant exposure to ABC blocks, cards with images of animals on them. This repeated exposure allowed us to learn and understand about the world around us. Past research has indicated that repetition is an important factor of learning for infants. Furthermore, other studies have shown that adults are able to learn quickly when exposed to repeated auditory noise. Previous studies relating to repeated imagery have been criticised as the tests that they conduct tend to be quite easy and participants successfully complete them. Thunell and Thorpe's study was based on visual stimuli. Their study aimed to further understand the effect that repeated rapid serial visual presentation, which simply put is repeated imagery displayed on a short time scale, and how this played a key factor in learning. They wanted to test whether individuals were able to recognise repeated images and be able to recall them. They did this by conducting 2 experiments. In the first experiment, Thunell and Thorpe aimed to test the effect of the number of presentations of a repeated image on memory and recall. The participants were required to complete 2 tasks. The first task was to identify repeated images in a stream that they viewed 1,000 images. Each repeated images may be seen 2 to 10 times throughout this stream. Half of the repeated images had 1 distractor image between them, and the other half had 2 distractor images between them. Whenever a participant identified a repeated image, they pressed a key on a keyboard. The second task was a memory test, which required participants to see 4 images and correctly identify the one that was repeated in the stream. They were then asked to respond from a scale of 0 to 4 how confident they were with their choice. The second experiment was aimed at testing whether the frequency of images presented had any effect on the identification. Much like the first experiment, there was 2 tasks in the second experiment, the stream test and also the memory test. In the stream test, there were 10 repetition sequences, and the number of repeated images shown was fixed at 5 images, and they all had 2 distractor images between the repeated images. Each stream that a participant participated in was set at a different frequency. There were 13 different frequencies that the participant could have got. These ranged from 4 Hz, where an image was displayed for 250 milliseconds, up to 120 Hz, where an image was displayed for only 8.3 milliseconds. If the rate of the stream was 60 Hz or less, then there was an 8.3 millisecond gap between each of the images shown. If the stream was 60 Hz to 120 Hz, there was no gap between the images. Each participant did both the no gap and gap stream. Much like the first experiment, the memory test was completed afterwards to see how many repeated images they were able to recall. The researchers hypothesized that for the first experiment, the added stimulus of having 2 distractor images makes for a longer processing time and therefore a slight increase in the reaction time. For the second experiment, the researchers hypothesized that at lower speed, the images can be processed on a cognitive level and the content of each image is easy to identify. The results for the first experiment's stream test found that if a repeated image was presented up to 7 times, it was easier for the participant to detect. It was also found that participants found it easier to identify repeated images with 1 distractor image between them rather than 2 distractor images between them. Furthermore, it was found that reaction times to identify repeated images were stable with one distractor image, whereas reaction time was longer when there were two distractor images. The memory task for experiment 1 showed very similar results, where performance was improved when the repeated images were shown up to 7 times. Correct answers were higher with the images that had one distractor compared to two distractor images. And interestingly, the researchers found that repeated images that were not identified during the stream were correctly identified during the memory task. The results of the second experiment during the stream test showed that the slower the frequency, the more repeated images were correctly identified, and that the reaction time identifying repeated images increased slightly with a higher frequency. The results of the second experiment's memory task found that participants successfully identified more repeated images in the slower streams compared to the faster streams. Also, when participants were rating their confidence level, their confidence ratings were higher with the images that were seen in the slower streams compared to the images that were seen in the faster streams. Overall, the study shows the brain's capacity to detect repetition and recall repeated imagery over a period of minutes. This allows for a positive correlation to be made between image rapid serial visual presentation streams and learning. However, more studies are needed to evaluate memory of repeated images over an extended period of time. Thank you.